So the title of this presentation is Hanging Up on Callbacks, more than just flow control with ECMAScript 6 generators. I came up with the title of this presentation, and I was so pleased with myself that I shared it with all my coworkers. It was like, you're done with callbacks, you're hanging up on them, right? And they all gave me the same face that you guys are giving me right now, so I probably ought to change the title of this thing. Anyways, if you can't be bothered to sit here and watch me talk about generators, you can see a bunch of working demos of ECMAScript 6 generators in action, assuming you have a web browser that implements generators as they currently exist in the ES6 specification, the draft specification. So if you've got a newer Firefox or Chrome Canary, you can just go to this URL and play around with stuff and ignore everything I'm about to say. Well, first of all, how many of you have worked with generators in JavaScript already? Yeah, a couple people? All right, what about fibers in Node land? No? Yeah, all right. Awesome. OK, well, you guys know everything. You can go home now, and I'll talk to everybody else. About me, developer at Carbon 5. I live in Los Angeles right now. I'm originally from Seattle. I like to tell that to people when I come up to San Francisco so they don't think I'm like a lame LA person. These slides suck, but basically, I'm an aging hipster. I live in Venice, so wear tight pants, right? Haskell. So what am I going to talk about up here other than just stand around and tell jokes? This is sort of the, this is what I would say is like common practice in JavaScript land. We've got some nested callbacks. We've got some plumbing of error messages from different asynchronous callbacks. It's a mess. Look at this code. Think about the kind of code that you write and wonder to yourself, like, can we do any better? Well, the answer to the question is yes, we can do better. It's about turning that code into something that looks like this. These two pieces of code functionally are identical. We're performing some asynchronous operations. We're doing let's just assume that the implementation of this get function issues an HTTP get to/foo and post issues an HTTP request to bar. We still have the single-threaded event loop. We're doing some plumbing of exceptions back to some centralized error handling, but we can do it in a whole lot less lines, and it's a whole lot less gross. So this is going to be about generators. This is going to be about making this dream your reality. So really what this is all about. It is my position that programming around asynchronous callbacks is hard. It's harder than it really needs to be. But because of the concurrency model provided to us by the browsers and also in Node land, it's just something that we've become accustomed to doing. ECMAScript 6, the draft specification, talks about generators, which I will demonstrate alleviate some of the pain that you're experiencing programming around asynchronous callbacks today. I'll show you how to leverage these generators to move from writing your code in continuation passing style, which would be like asking the computer to do something and then at the same time passing it instructions for what to do next, callback, to direct style programming, which is what you're going to see in like Python or Ruby or all these other programming languages where you can do x equals get to some URL, and you don't move down to the next line until that operation is completed, without losing all of the magic of the single-threaded JavaScript event loops that you love and know today. OK, so in order to talk about how awesome generators are, I need to enumerate some of the things that I think suck about working with asynchronous callbacks. It is my position that it is a non-trivial amount of effort to follow the path of execution through a program that is written leveraging heavily asynchronous callbacks. If you write JavaScript all the time, you sort of just become numb to this pain. But people coming into the language from Ruby, Python, Java, whatever, have to wrap their head around some of the strange things that they're seeing. They do things like this. We've all done this the first time that we started writing JavaScript. We're issuing an HTTP request to /token. We're using the result of that to issue an HTTP request to /profile using that token. So we're doing two asynchronous things in series. And then when we finally get that last result, what we would like to do is output the profile name to the console. We all know, because we're awesome JavaScript people, that we have to put that in there. And all this nesting is somewhat significant, and these nested functions imply an order of operations that you can't get by simply going top to bottom. That kind of sucks. I'll also demonstrate that handling exceptions across event loop ticks is a pain. So I showed you this in the first example. Look at this code. Look at this code and think about what it's doing here. So assume that this call to sumlib.getData is a synchronous operation. So this synchronous operation being what it is, I can catch errors with a simple try-catch block that is built into the language, right? That's good. But if I have errors that arise inside of the callbacks, if I have errors that are given to me as a result of some asynchronous operation, and I want to handle those things in the same way, I have to plumb that error back to some centralized exception handling mechanism by virtue of a closure. That's kind of a bummer. You can alleviate some of this pain by using promises, but it's a whole lot of moving stuff around to try to handle the fact that you can't you can't easily catch errors that arise across different ticks of the event loop. That's a bummer. I think we can do better than that. So as I was mentioning, this sumlib get data, if an error arises from the call to get data or something inside of that, a synchronous operation, I can use try-catch, which is built into the language. It'll pump it back to this onError function that I've got at the top. But if anything happens here, I have to pass this stuff up via closure because they're not happening in the same tick of the event loop that this try-catch is being invoked. Last thing I want to talk about, async flow control is hard. It becomes easier when you use some libraries like promises or when you use async, but it's harder than it needs to be. And if you want to do it in just regular JavaScript, you're going to have some problems of legibility. So looking at this code, who can tell me what it's doing at a high level? Anybody? Straight faces. OK, I'll give you a hint. It's doing two things at the same time. It's issuing this request to get token, and it's issuing a request to get key. And when both of those things are done, then we're going to issue a post to auth. And then after that's done, then we're going to redirect to dashboard. And what I'm trying to demonstrate here is doing two things concurrently, and then something else in series. So there's all sorts of lame stuff I have to do. I've got this laser pointer that helps me point. There's all this lame stuff I have to do to make the callback to this request know about if this thing is done such that we move on to login. We can alleviate some of this pain by using promises, but it's still a lot of code. It's a little easier to understand, especially if you're familiar with the Promises API, but the same sort of thing is happening. I'm doing two things concurrently, and then I'm doing two things in series. We can use async to do this, but my God, look at all that code. It's verbose, it's explicit, but that is a lot of code, and I think that we can totally do way better than that using generators. OK, so what are generators? I'm not going to read all that to you, but generators are essentially functions that can suspend midway through their function body. So we're used to functions that you enter at the top and you exit out of the bottom. They either return something explicitly or they return the implicit undefined. But generator functions are different in that you can re-enter them in the middle. Why that is interesting, we'll talk about in a second. You may be rolling your eyes when I'm talking about ECMAScript 6 because you have to support IE7 or whatever thing you have to do in your miserable job. But you can use some of these features in ECMAScript 5 compliant browsers today as long as you're willing to transpile with Google Tracer. Or if you're building some rad admin tool and you can use one of these newer browsers like Firefox 27. I'm not sure how far back you have to go with Firefox before you get support for these APIs, but I'm using Firefox 27. It's working today. Chrome Canary will work. And you can use this stuff in Node right now as of Node 0.11 with the Harmony flag. So you can actually start using this stuff. OK, so generators. I talked a lot about how they're awesome. I'm going to show you the syntax, and we'll slowly move from like the hello world of generators into something that will enable you to write real code in your applications today using this direct style that I've been talking about. OK, so the hello world of generator functions is an iterator. There's some interesting syntax here. Well, first of all, let me back up. What we're going to do here is we're going to output the Fibonacci sequence of numbers. Instead of having to generate some huge chunk of Fibonacci sequence, some huge chunk of the infinitely long range of Fibonacci sequence numbers, we're only going to generate them one at a time. So in order to do that, we're going to use a generator. It's got some interesting syntax that you may or may not have seen before. First thing to note is the asterisk after function. That denotes that this function that we're talking about here is a generator function, which behaves fundamentally in a different way than a regular function that you're used to in JavaScript. The other new word you're going to see here is yield, which can only be found inside of generator functions. So imagine the code on the left is the definition of Fibonacci sequence, and then if you moved this chunk of code underneath it, it's all in the same program. I just couldn't fit it all on the screen top to bottom. So we'll see how the caller and the callee sort of bounce back and forth, giving control depending on the state of the generator function. OK, so first thing we're going to do, we're going to invoke our generator function. That is going to return a generator object, which we're going to store in this variable seq. That has not executed the body. We haven't started executing the code in the function body yet. We just initialized this generator function. Now we have a hook to this thing called a generator object. So the next thing we're going to do is we're going to call next. And next is going to start evaluating the code in the body of the generator function from where we left off, in this case, at the very top of the function. So we're going to do our variable declaration. We're going to do some assignment. A equals 0, B equals 1, C equals 0. We're going to hit this while. We're going to go into the while block, and we're going to continue evaluating code until we hit a yield. If this were not a generator function and you did not have a yield there, this would just be an infinite loop, right? I've got like while true. And as we know, while true will just keep going until something makes it stop. Generator functions are a little different. We're evaluating into this while loop. We hit this yield keyword. We evaluate the right side, the expression found on the right side of the yield keyword, and then we suspend the generator function. So we do not move down to the next line, which does this assignment, C equals A, B, B, C, B, and all that other good stuff. So we evaluate, as I mentioned, we evaluate the right side of this yield function, and we suspend, giving control back to the caller. And what we yield, this expression on the right side of yield, will be made available as a property of the object that we return. So using substitution, just as a thought exercise, A was equal to 0 the first time around. So when we yielded control from the generator function back to our regular code, the value of A substitutes in for value on the right-hand side. So then we move down to the next function, the next line. We call next, and we re-enter our generator function immediately after the yield point. So not at the end of the line, but like immediately after this expression A right here on the right. So then we move down to do this, assignment, C equals A equals B, B equals C plus B, moving to the next number in the Fibonacci sequence. We go back to this while true, which is still true, and then we hit our yield point, once again, freezing the generator function, giving control back to the caller, and returning the value of A, which is then available via the value property of the return object here. So using substitution, you can see that we now have 1. You can kind of see where I'm going here with this. You can mentally map. We're going to do the Fibonacci sequence of numbers, and you can sort of see how we're bouncing back and forth between the generator function and the code that is invoking the next method on the generator object that it's got a hook to. So I realize this example is a little lame, but it is important to understand the very basics of this thing, or you'll get totally lost when we get into the more complex examples later. So visualizing multiple entry points, the Fibonacci sequence is awesome, but we can get a little more complex visualizing what I was talking about, where you're re-entering a program not at the end of the line, not at the beginning or the top, but somewhere, at the end of an expression. So, OK, looking at this code, I bet somebody can guess. Let's just assume that log is an alias for console.log. Can somebody tell me, and I'm not going to keep going until someone tells me, what is going to be output in the console when I evaluate this code right here? You have 5 minutes. Come on, somebody brave. Huh? Oh. All right, yeah, what do you got? Matt? 100. You are going to see something like 100. All right, that was good. We'll keep going with this. You're fired. OK, so we saw before that the first thing you're going to do with your generator function is you're going to invoke it, which is going to give you back this generator object, which has these methods, next, and so on and so forth on there. So first step, invoke pow generator. We get a hook back to the generator object, which we then store in variable g. Next line, we're going to call the next method, which is going to start evaluation of the code in the pow generator function body from top to bottom. So the first thing we do, we're going to declare the variable result. Then we are going to keep evaluating code on the right-hand side, obeying the order of operations that the language enforces, and we're going to find this first yield keyword. So not both of them, but just the first one. We're going to evaluate the expression on the right-hand side of yield, and we're going to suspend the POW generator function, which makes the value that we yield as the result of evaluating that expression on the right-hand side of yield available to the caller. So at this point, substitution, the string A is now output to the console. It's important to note that this POW generator function is now suspended. It's in a suspended state. You can read the ECMAScript 6 specification that talks about the different states that functions can be in, but generator functions introduce a new state which is suspended, which this function is in right now. Okay, so next thing we're going to do is we're going to move down to the next line. Parentheses enforcing an order of operations is going to ensure that we're going to call next first before we output anything to the console. The interesting thing that you're seeing here, which we didn't see in the iterator example before, is that now instead of just receiving values from the generator function, we're going to pass something to it. So we're going to pass the number 10 from our caller to the generator function, the callee. And what that's going to do is it's going to take this value and it's going to essentially insert it immediately at the point in which we suspended the generator function before. Then we're going to continue evaluating because now the generator function is back in an active state. We're going to hit our next yield point, which is going to send B, or make B available back to the caller, and suspend once again. So as substitution, you now have A and B. The caller has control. The generator function is suspended. So you can sort of see where I'm going with this. We call next, passing 2, which substitutes 2 in at the point where we suspended the generator function before. And then, since there are no more yields, we're going to continue down until we hit a return statement. So we're going to do some assignment. We're going to evaluate math.pow, which raises 10 to the power of 2. Thank you, Matt. We're going to store that in the variable called result, and then we're going to return it, which makes it available as the property value of the return object that we're going to get from our call to next. So it's kind of a trip, right? A, B, 100. You can see how we're bouncing back and forth between the generator function and the caller. Yeah, what's up?
And if you didn't put the A and B as the input values, would this still have worked?
Yes. You can yield whatever you want. It could be undefined. A and B are there mostly to illustrate the back and forth sort of nature of this.
What would have happened if you would make one more line that says like g.next 3?
If the generator function is done, I forget the name of the state, but if the generator function is done, you'll get an exception raised when you attempt to tell it to resume again, because it can't do anything else. There's like a finished state, I believe is what it's called in the ECMAScript 6 specification. All right, I'm going to keep cruising, because I know you guys want to get to your 15 seconds of fame. OK, so generators in the real world. Fibonacci sequence number generators are awesome. Raising 10 to the power of 2 is really cool, but like we build real stuff that we got to get paid to do. So how does this stuff apply to your job, right? I talked about how using asynchronous callbacks, it's kind of a pain in the butt, especially for a new developer to follow the path of execution through a code that relies heavily on asynchronous callbacks. This is what I showed before with a slight modification. We're still doing our request to get token. We're still doing our request to get profile. We're doing these things in series, and then we output to the console, your name is Billy Bob or whatever. Using generators, we can clean this up a little bit. If what we really want to do is communicate that we're doing 3 operations in series, there's no need to do this nesting of callbacks like you're accustomed to in regular old JavaScript land. These 2 pieces of code functionally do the same thing. Do the get to token first, do the get to profile second, and then output this stuff to the console. Uses generator functions to do that. We'll talk a little bit about it in the next slide. Something you're seeing here for the first time is this sync function. And this function does, it reduces some of the boilerplate that you have to do in order to suspend and resume and pass values around. There are a variety of libraries out there right now that already provide this functionality for you. GenRun is one of them. Corec, I think, is another one. If you Googled like generator wrapper libraries for JavaScript today, there are a ton of them out there. The reason that I'm talking about sync, which is something that we'll implement in this conversation today, is just so you can see how you can write a very small amount of code to get this direct style programming feel, which you're going to see here. So sync. Sync takes a generator function. In this case, it was an anonymous generator function. You can tell it's got the little star there. It is going to immediately invoke the generator function, which gets you back that generator object. What it's going to do is it's going to pass a function. It's going to pass this function called resume, and then it's going to immediately call next, which is going to start evaluating the generator function from top to bottom. The interesting thing about this resume function that we're passing the generator is that we can pass that function as the callback to our asynchronous operations, and when they are done, they, via a closure, will restart our generator function, passing whatever value they got from their asynchronous operation. Does that make sense? You can see this resume is passed to the generator function, and I just passed this resume function on to my asynchronous operations as their callback function. I cheated a little bit in this presentation. The signature to resume follows the node style error first and then return value syntax. I kept going with the browser examples that I've got here because it serves as talk really well. But many of the libraries I'm talking about, like GenRun and Jenny, will handle this more intelligently for you. But ultimately, what they do is they pass a function which will allow you to resume the generator function that your code is running in. OK, so I talked about how much of a pain in the butt it is to plumb exceptions around across different ticks of the event loop. Generators have an answer to that as well. In the first example, I showed you that the try-catch only works with code that could raise an exception on the same tick of the event loop that the try-catch block was evaluated, which doesn't do us any good if we want to raise an error from inside an asynchronous callback and handle it in the same place, unless we do this like lame plumbing of error messages through closures. With generators, you can use try-catch, which is built into the language, right? Like built into the language to handle the exceptions that are raised from the result of evaluating synchronous code as well as asynchronous code. It's kind of interesting, right? You don't get that with regular JavaScript. The way that it works, with a slight modification to our sync function, is that we can, instead of resuming the generator function faulting in a value, we can resume the generator function immediately raising an error at the point that it's suspended. So assuming that, let's say, my call to post bar raised an error, or rather like an error that I want to re-raise like happened, I can easily resume the generator function calling raise, which immediately after the yield and its expression, we will raise an exception, which we can then catch in the try-catch block that is built into the language. The last thing I want to talk about is async flow control. I showed some examples of using promises and the async library, and also just vanilla JavaScript to do some things in parallel and then a couple things in series. The syntax was a little brutal, but we just sort of learned to accept it, and that's what we're just kind of accustomed to it. We don't have to do it anymore. As I said, this is the old school way of doing it. This is the new school way of doing it. New school, I'm totally LA. So what we're doing here, just like in this prior example, where we're getting token and we're getting key, and then when we're done with both of those operations, we move on to posting to auth and then doing this redirect. We can do this in much fewer lines of code, much less clutter, and it's pretty clear what we're doing. I had to put this array on 2 lines to fit it in the slides, but the API looks pretty clean, in my opinion. You'll notice that there's been a modification to the function that I'm the modification to the function that I'm passing my anonymous generator function that enables us to do some things like handle multiple operations concurrently. I won't show the implementation of this, but if you look at my GitHub, I'm github/laser with an S. I've got a super trivial implementation of this. But basically, what's going on here is get to token and post to key happen at the same time. When they're done, the generator function resumes, and then the variable data holds an array with 2 things in it. First thing is a result of get token. The second thing is a result of post to key. Then in series, as the next thing in this series of things I want to do, I do a post to auth, passing the data that I got from both of those two asynchronous operations. When that is done, I have auth holding, the variable auth holding the result of this post to auth. And then I move down to window.location.href, changing the URL and passing whatever I got back from post to auth. So it's pretty clear to differentiate between the things that you want to do concurrently and the things you want to do in series. It looks very similar to something that you're going to find in a programming language that typically uses the direct style, like Java, Python, whatever, only you're not losing any of the power of the single-threaded event loop. You're just suspending the generator function until this asynchronous operation completes.
What is the resumer argument in that last one?
So the resumer argument, notice instead of just passing this thing dumbly along as the callback to these asynchronous operations, I'm actually invoking it here. That is a modification I had to make to sync. Basically what it does is every time you call it, it increments a counter. And then when the generator function suspends and gives control to the sync function waits until the counter has been decremented, which happens when each one of these asynchronous operations completes. When the counters have been decremented back to 0, then it knows that it can resume the generator function, passing back whatever array of stuff it has as a result of all these asynchronous operations. It's something like, I don't know, like 20 lines of code or something like that. But if you see me after the presentation, I'll give you a link to where you can see that in action. But it basically reduces to just incrementing a counter and not progressing to the next bit of code until that counter has been decremented, which happens when these asynchronous operations complete. Yeah, what's up?
What if, just say you have a situation where you don't want to keep a data request open for more than 2 seconds, you want to cancel and say go to an alternate server. Can you kill a pending yield action?
Can you kill a pending yield action? I don't think so. If I understand your question, the answer is no. But it's possible. We can talk afterwards and see if you have a specific example. But to kill yield, I don't know how you would do that. In fact, I don't think you can do that. OK. So takeaways. Walk through all this code. I talked about direct style versus continuation passing style coding a lot. Using generators enables you to write direct style coding without losing any of the awesomeness of the single-threaded event loop that you use and love in the JavaScript runtimes you're programming against today. You can already use these features in Canary. You can already use these features in certain builds of Firefox. You can already use these features in browsers that implement the ES5 specification as long as you're fine with the transpile step. If you're using CoffeeScript, you're already doing some transpilation right now. It's not that big of a deal to go plug in another piece into that pipeline if you really want to try some of these features in your browsers, in your applications today. It is my position that their adoption will dramatically change the shape of the asynchronous JavaScript code that we're writing. I think the syntax is easy enough to understand that it will make JavaScript accessible to people that otherwise bang their head against the wall trying to understand the asynchronous nature of these runtimes. This totally reduce, well, it doesn't totally reduce that pain, but it really helps to alleviate a lot of that pain. I encourage you to go experiment. Check out that es6-gen.herokuapp.com if you want to see some working examples from the stuff that I've talked about today. I want to give some acknowledgement to Toby Ho, Tim Caswell, and Andy Wingo on the V8 team. These fellows have excellent blog articles and have been talking about generators in JavaScript for a long time, back into the JavaScript 1.7 Mozilla days, I don't know, which several years ago. Andy Wingo also has an excellent blog article that he wrote about ECMAScript 6 generator performance in V8. So if you're going to give me a stump the speaker type question and ask me about performance and generators, I'll just point to that link and tell you to go forth and read. Follow me on Twitter, Lazericus, GitHub Laser. Like I said, es6gen.herokuapp.com for working code. You can look at the source, obviously. Swenson-Heeley.com presentations generators if you want to get hooked to these slides and step through that weird bouncing back and forth between the generator and the caller stuff yourself. I blog at Carbon5 for Carbon5 and myself and you. You can find it blog.carbon5.com/author/Aaron. Thanks. Do you have any good questions? Yes.
Yes. So would you recommend this thing over, say, Node's async one?
Yeah, sure, yeah, I think so. Oh, yeah, sorry, right. So the question was, would you recommend this over Node's async module? I presume you're talking about the JavaScript async library. Yeah, I find that as long as I am programming for a runtime that's going to support this API, I have really enjoyed using this API instead of async, which has been my go-to. I've been resisting promises forever using the async because I find that its API is pretty easy to understand. This, I think, goes a step further, as long as your runtime is going to support it. Yeah, what's up? That's an interesting question. Your stack traces look pretty weird with these generator functions. So the answer is it depends. You have to do a little bit of extra work. Some of these libraries that provide this functionality that I showed with sync actually do some interesting things when you're running in like what they call debug mode, which will make the stack traces legible. But out of the box, stack traces can look pretty weird. I think that, I mean, the ECMAScript 6 specification is still in a draft state. So I would imagine that when that is no longer in a draft state and browsers are really starting to put a lot of effort into building these generator APIs, that you'll be better enabled to debug these things than you are right now, given their sort of like beta-esque nature. Yeah, I was just reading the Andy's blog because I wanted to prepare myself for this question when I was in front of you all. And he said something which is always like my go-to when folks are talking about performance in web applications, which is to say that you're probably going to be sitting around waiting on I/O. So the tiny amount of time that you're going to spend, if there is any additional CPU time that you're going to be spending working with generators, is probably going to be trivial relative to the amount of time you're going to be spending waiting on I/O. I realize that's a totally lame, like hand-wavy question, or excuse me, hand-wavy answer. But specifically, Andy goes into the details of doing a problem without using generators and doing a problem with generators, and he found that the difference between his implementation A and implementation B was a matter of like tens of milliseconds. You'd have to look into his actual test to like find out if that's a number that means anything to you, but I totally ignore that problem, given the benefit of legibility that these APIs like afford developers like walking into projects where I've written code over the regular asynchronous stuff that I've been writing for 8 or 10 years or whatever. Cool. Thank you very much. Thanks, man.